With our suspension all set up, let's get our vehicle moving. We'll need to tackle steering and some basic tire friction to get our vehicle moving about. In Unity, create a script and name it Steering and open it up. In an ideal world, when your vehicle turns, you want to be able to draw a line from each of your wheels towards a center pivot from where the vehicle pivots, ensuring the wheels don't fight each other. Doing this requires the outer wheel to follow a circular path that's larger than the inner wheel, meaning the inner wheel must turn in more than the outer wheel. We achieve this through what is known as Ackermann steering geometry. In the real world, we'd achieve perfect Ackermann geometry if we were able to draw a line from the wheel's steering axis through the ball joint connecting the tie rod and to the center of the rear axle. In our simulated world, however, we're able to freely set the steering angle of our wheels and must use the Ackermann formula to achieve our desired steer angle. Back in our code, we'll first create an enum to set the steering behavior of the wheel and define our wheelbase, rear track width, and turning radius. We'll then save two variables for player input and the resulting steer angle. The steering input will be interpolated from our raw horizontal input axis by using Unity's Move Towards function. We then calculate the steer angle based off the Ackermann steering formula and apply the correct Ackermann equation based off the steering behavior and the direction we're turning. Finally, set the rotation of the top link to the calculated steer angle. This will become important later for when we calculate our wheel's direction vectors. Save the script, attach it to our 4 top links, and configure the wheelbase, track width, and turning radius, and set the steering behavior of each wheel. Hit play and try turning your wheels side to side. It appears our steering script is working. What's left is to have our wheel meshes update accordingly. Open up the Visuals script and create a reference to the steering script and update our meshes rotation based off our current steering angle. Save the script, attach the reference, and hit play once again. Looks like we're ready to get our vehicle moving. In classical mechanics, we model friction with the following equation, where F is the friction force generated, N is the normal force the surface exerts on the object, and mu is the coefficient of friction, a unitless value used to indicate how grippy the contact between the object and surface is. It is important to note that the direction the force of friction points in opposes the direction of motion or impending motion. Bringing this concept to a wheel, when we spin a wheel like so, the direction of impending motion follows the circular motion of the wheel, and thus the friction generated points in the opposite direction, pushing our wheel forwards. In Unity, open the wheel script back up again. Create 3 new methods called Get Wheel Motion on Ground, Get Simple Tire Force, and Apply Simple Tire Force. We'll call these methods in that order after our suspension code. In the Get Wheel Motion on Ground method, we'll calculate the lateral and longitudinal directions of motion of our wheel, as well as the wheel's linear velocity, a value we'll take a deeper dive into once we discuss slip-based friction models. Next, in the Get Simple Tire Force method, calculate the longitudinal and lateral tire force based off the friction formula, multiplying them with the negative direction of motion. Finally, in the Apply Simple Tire Force method, add the tire force to our vehicle's rigid body at the tire's contact patch. Save the script and go back to our Visuals script. In there, create a variable to store the wheel's rotation and increment it like so. Apply it to our wheel's roll axis along with the steer angle we calculated previously. Save the script and set the coefficients of friction for both the lateral and longitudinal directions, and then hit play.